Okay, let's have a little look at the basics of the 11 times table. Really want to focus on the ones that start about here. This is where they start to get a bit interesting, these ones here. But as you'll notice, there's a bit of a pattern. When you go right up, all the way up to 9, anything times 11 is just that digit repeated. So 1 times 11, 11. 3 times 11, 33. 6 times 11, 66. So we don't even have to memorize these. So long as you know that anything times 11 up to 9 is just the same digit repeated, you're set for your 11 times table up to 9. Perfect. Where it starts to get a bit more interesting is when the numbers get bigger, and I want to show you a trick in a second. First of all, let's have a look at these three. Now these ones are usually taught, because we go, for some reason we go up to 12. I think it's an old-fashioned idea. But let's have a look at this. Now 10 times 11, I would go back to your 10 times table for that, because all I have to do then is multiply that by 10, and it's the same as gluing your 0 on. Now I know mathematically that's not what's really happening, but in a practical sense we can just think, well, it's that with another 0, we've shifted its place value across. It's worth 10 times as much. These ones here, more interesting. 11 times 11, 121. 12 times 11, 132. Now it's worth memorizing those two because they come up all of the time. But what I want you to have a look at is this, and this leads to the next thing. 1 plus 1 is 2. 1 plus 2 is 3. This is a pattern that emerges that we can use to figure out 11 times any 2-digit number. And I'll explain that in a second. I'll just pause this for a second. But when you're starting to memorize your 11 times tables, just make sure you focus on these three, and those are the ones that will get you out of trouble later on when it comes to tests and things. The rest of them you don't need to memorize. You just need to know that 4 times 11 is 44, and it's a pattern that works all the way up to 9. Okay, time for the next thing. I hope you like this one. So how can we use what we know about the 11 times table to solve 11 times 2-digit numbers like this? Well, there's a super duper easy trick which I think you'll love. The way I would approach it is this. The only maths I really need to do is to add 3 and 5. So I know in this case it's going to be 300 and something 5. There's a thing in the middle. 3 plus 5 is 8. 35 times 11 is 385. How quick is that? I don't need to do any tricky multiplications. I just kind of split those two numbers apart, add them, and chuck in the sum in the middle. Let's have a look at this one. 43 times 11. I know 4 plus 3 is 7, so my answer will be 473. It's a neat trick that you can learn to do in your head. Now, why have I put these ones over here? They're a little bit different. The reason they're different is because you can tell straight away that the sum of 7 and 8 is going to be bigger than 9. What do you do in that case? Well, then it's a very simple carrying kind of thing. In this case, we know that 7 plus 8 gives us 15. I can put the 5 in there and carry the 1. And that means I just add those two. So it would end up being 858. Pretty easy trick, right? Works with any of them. Now, there's only one more step than these ones. The only difference is I've had to carry over the bit that doesn't quite fit in the middle there. Otherwise, it works the same. Look at this guy. You know, 6 and 5 comes to 11. I can put the 1 in there, carry the 1. That means that it's going to come to a total of 715. Super quick, easy way to do it. You can learn to do this in your head as well. Just a little bit harder, but a groovy party trick you can impress your friends with. The 11 times table. Gotta love them. So I've put up some fresh ones for you to try for yourself. So what you could do here is pause the video for a little bit, have a go for yourself, write it down in your own maths book, see what you come up with, and we'll compare answers at the end. Hopefully, even by the time you're getting down here, you could be starting to do them in your head without even having to write anything down. So just pause it here. I'll come back in a sec. All right. We know 2 and 4 are 6, so the answer will be 264. We know 6 and 2 is 8, 682. We know 5 and 1 is 6, 561. How are you going so far? Good stuff. All right, so this one here, a little bit trickier. 3 and 8 comes to 11. That's okay. I can add that one onto there straight away. I could make it 418. 7 plus 7 is 14, so that's going to make it 847. And 9 plus 4 is 13, so it must be 539. So you can start to do it in your head. If I can do it, you certainly can. I hope you enjoyed that. We're going to look at multiplying bigger numbers by 11 next. Yesterday we learned the trick when we're multiplying by 11 that you can, say, take any two numbers like 53 times 11, and to figure out that multiple, what do we do? What do we do to this?
Add 5 plus 3 and put the answer in the middle.
So 5 plus 3 is 8, isn't it? And then we just pop that 3 there, 5 there, and it equals 500. Equals 583. So it's a really simple trick that we can use. And I'll show you how that works in a second, but please don't blurt us. Okay, now, remember it's on video, guys. So, really simple trick, and we'll go back over that at some other time. The other bit that caught people out was when the number added up to more than 9 here, but then it was just transferring trick, and we'll sort of develop that idea in a second. So if you had 85 times 11, of course 85 comes to 13, doesn't it? Yeah, so we still do the same sort of thing. We put the 5 there, we put the 3 there from the 13, and just add 8 and 1 there to get 935, right? So that was the way around that, and it's like carrying 1. It's a nice simple way to do it. It's just one more step. But what I wanted to talk about today is how you can multiply any number by 11, and it's really easy. It's not any more difficult than just adding two numbers together. Okay. So bear with me for a second, just pause the video for a sec. Okay, so when I point to you, just give me a digit, just a single digit.
1.
Cool.
2. 7. 4.
Nice.
5.
Excellent. Nice juicy number. And we want to multiply that by 11, right? So that's our next trick. And it seems like it's going to be hard. But remember what happens when you multiply any number by 1. What is it?
Itself.
Itself. Perfect. It's the same number, isn't it? And again, we're talking about 110 here. So we can use that to help us multiply any number by 11 just by using addition. Because we know we don't have to multiply anything here. There's no brain power involved. It's 4,175. That's 1 times that, right?
Yeah.
This is 10 times that, and we also know that 10 times anything is related just by
A 0.
shifting the place value. It's a little bit like gluing a 0 onto the end, isn't it?
Do you just put the 0 on the end of
So just pop a 0 here, because that's indicating that everything after that is going to be 10, have a value 10 times more. We just copy this down again. 4175. And then add those two together. Am I still in the shot there?
Yep.
Cool. Alright, so you can help me with this. 5 plus 0 is?
5.
Good. 7 plus 5 is?
12.
12. Good. To carry the 100 up here with the other hundreds. 7 plus 1 plus 1?
9.
9. 4 plus 1,
5.
and then we don't have to add anything there. So our total number, 45,925. So even though it's multiplication, really all we were doing is adding, right? And we know how to do that. That's nice and easy. It's just the standard form algorithm here that we can use to figure that out. And we didn't really have to do any maths to get to that point, did we? We just copied the number down, 4175, and added that times 10 and get a total that way. And that's kind of how that other trick works, where the number goes in between. So if you were to do it with, what was the one we did before? Can't even remember now, but we'll pick another one. Say 35, might have been that one. And we multiply that by 11. It's the same sort of thing, right? It's just that there's a quicker way to do it. But if we go 35 plus 350, it's kind of stepping it out by one place value, right? So we get the 5, we get the 8, and we get the 3. It's the same as going 3 plus 5 is 8 equals 385. So it's the same trick, it's just a short version of it. Do you see what I mean? Yeah. And to answer your question before about how does this trick work, it's a really short version of what we're doing here with an algorithm. This here allows us to multiply any number by 11 really, really easily and quickly anyway. Okay, so it's just a bit more spread out, but allows you to deal with much bigger numbers easily. Make sense, guys? Yeah. Alrighty, thank you very much. I've got something for you, so just pause it there, hun. Okay, so have a look at these questions here. These are some extra for expert type questions with the 11 times table. Pause the video here, have a go. I'll put some answers up in a second, see how you went. So let's see how this goes. As it turns out, multiplying by 11, as we talked about, is super duper easy. So in this one here, good example, we just copy 597 because 1 times that is that. Then 10 times that, also easy. Pop the 0 in before we forget. And what I haven't done is left myself enough room there, but you guys can give yourself more room when you do it. So that's going to give you an answer of 7 there, 9 and 7 there, 6, carry the 100. That gives you 15 hundreds. So a total answer of 6,567. Similarly, we can do this one down here. Copy it down, I'll make sure I don't go off the edge of the screen there. One of those. Super easy way to do it. Pop in the 0. Another one of those, 4075. Just check I'm still on the screen there. Oh, good, plenty of room. Then put 5 down there. 7 plus 5 gives you 12. 10s, carry the 100 up to here. That's another one that gives you 800s, 4,000s, and 40,000. So total of 44,825. Pretty easy, really. Didn't have to multiply much at all. This really becomes an addition question. So what happens if we try it with a novelty question like this? Well, it's much the same process. It's really not hard. Copy down a bunch of 9s. Pop in a 0 there. The only thing we're going to get is a lot of repetition, really. So 9 is going to be our first number. 9 and 9, 18. Carry the 100. 9 and 9 is 18 again. Plus that 1 gives it 19. Carry the 1,000 up to here with the other 1,000. Again, then of course that gives you again 19. Carry that one up to there. So you'll end up with 109,989. Now this one here, the only difference really is the decimal. But does it matter? No, not really. Again, because we're multiplying that whole thing by 1, 257.5, multiplying it by 10 is also easy. We don't have to put a 0 this time, we can put a 0.0. Might make it easy to remember what we're doing. Then just copy those numbers then in the same sequence. We've just multiplied it by 10 and then add it up again. So we're still going to only have 0.5. Don't forget to put in the decimal. Do remember, don't forget. Then 7 plus 5 of course is 12 again. That there. Then that becomes 13 tens, carry the 100 up to there, a total of 8 of those, 200. So you end up with 2,832.5. Not really hard. Let's have a go at this one up here, same sort of deal. The difference is that in our decimals, we have 2 places instead, but it doesn't matter. Because we're multiplying really by 1 or 10 or whatever, it becomes very, very easy. So again, we just copy down the whole number, 693.25, pop a space there so we can remember what we're doing, decimal there, and then just copy the numbers in reverse order is an easy way to do it. So 5, then 3, 3, 9, 6, reverse order. Then add those all up and we'll get our answer. So that's going to be 85.85. 3 and 3 is 6, 9 and 3 is 12. Carry that 100 up to there, which gives you 16 hundreds. Move the 1,000 up to there, you end up with 7,626.85. It looks complicated, but the process is really, really easy. Okay, then last one here. The number is small, it starts off less than 1. There's a lot of decimal places, but we can still multiply it by 11 in exactly the same fashion. Start off with 0.56324, that's multiplied by 1. Then we're multiplying that by 10. This time we're shifting the place value across here, keeping the decimal in the same place. Just the same sequence of numbers, 5.6324 in this case. 4 and nothing is 4, 6, 5, 9, 5 and 6 is 11, carry that up to there. Total answer 6.19564. So, looks complicated, but broken down into steps becomes really, really easy. How did you do?